Hello everybody, welcome to Functions Notes Day 2. We're actually on day 19 right now, so let me fix this for you. Okay, this is day 19. Alright, we're going to start out with various ways to represent functions. The first way we have is a verbal rule. In this example, the output is 1 less than twice the input. Now the output would be your y value. Is equal to, so our equation would be y is equal to 1 less than twice the input. The input would be your x value. So twice the input would be 2x, and 1 less would be minus 1. So if we were to fill out the input-output table, if you had an input of 1 for your x value, you plugged in 2 times 1, you would get 2 times 1 minus 1, which would be 2 minus 1, which would be an output of 1. An input of 2 would give you 2 times 2 minus 1, which would give you 4 minus 1, which is 3. And then you'd have 2 times 3 minus 1. That would be 6 minus 1 is 5. And 2 times 4 is 8 minus 1 is 7. Okay, so we'd get our appropriate y values or our outputs, and we can graph each of these ordered pairs. Okay, the ordered pairs would be, we would have 1, 1, 2, 3, 3, 5, and 4, 7. So if I graph them over here on the graph, 1, 1 would be right here. Then we've got 2, 3, 1, 2, 3. We've got 3, 5. And we've got 4, 7. 1, 2, 3, 4, 5, 6, 7 here. Okay, in this example, our domain would be the set of values 1, 2, 3, 4. So the domain is your input values, and your range would be your output values. So that would be the set of 1, 3, 5, and 7. Okay. The next example that we have, we've got the output is 1/4 of the input. I want you guys to change your notes to be 1/2 of the input, okay? Just so that our graph lines up a little bit better. So that should be 1/2 of the input. All right, so if we want to write the equation, the output is your y, is 1/2 of the input, which is your x. So if we had an input of 0, 1/2 times 0 would be 0. 1/2 times 1 would be 1/2. 1/2 times 2 would be 1, and 1/2 of 4 would be 2. Okay, so now our ordered pairs would be 0, 0, 1, 1/2, 2, 1, and 4, 2. Okay, if we graph them, 0, 0, we've got 1 and 1/2, 2 would be a 1, then we've got 4 and 2, so it would look like that. In that example, our domain would be the set 0, 1, 2, and 4, and our range would be 0, 1/2, 1, and 2. In this example, it would be a function. Okay, so moving on, now we've got a graph, okay, and I can fill out my table with the ordered pairs. So with an input of 3, I would have an output of 4. An input of 4, looks like my output is 3. Input of 5, my output is 2. And input of 6, my output is 1. So looking at that, let's see if we can come up with what the equation is. Well, y is equal to, and if you notice, all of these add up to 7, so it looks like the equation would be 7 minus our x. So if we had an input of 3, 7 minus 3 would give us our output of 4. So the verbal rule could be the output would be, the output is 7 less the input. Notice it's not less than, it's just less because the 7 comes first. Okay, so taking the next step, we've got evaluating functions. So remember yesterday, our last class, we talked about h of x. This is how this is read, h of x. Well, in this example, h of x is equal to 3x minus 2, but we want to find h of negative 6. All that means is we're going to take the negative 6, and that's what our x value is going to be. So we're going to let x be negative 6. And when we do that, we plug it into this expression right here. And we've got 3 times negative 6 minus 2. Trying to figure out what our output is. This would be negative 18 minus 2 is negative 20. Okay, so h of negative 6 is actually equal to negative 20. Or, as an ordered pair, an input of negative 6 would give us an output of negative 20. All right, now here we have a g function. So it says g of n is equal to negative 2n minus 1. We're finding g of 8. Okay, so let's let, in this example, n is going to be equal to 8. Okay, so I'm going to plug in negative 2 times 8 minus 1. This is negative 16 minus 1 is negative 17. So g of negative 8 is actually equal to negative 17. As an ordered pair, the input of 8 would give us an output of negative 17. Okay, so we're just taking that and placing it in for the variable. All right, f of a, in this case, we're going to let a be equal to 8. Okay, because here we have f of a, we are looking for f of 8. So in this example, negative a would be negative 8 plus 5, which would be negative 3. So f of 8 is actually equal to negative 3. All right, input of 8, output of negative 3. All right, and we're going to find g of negative 5, so let's let n be equal to negative 5. Negative 3 times negative 5 plus 3. Negative 3 times negative 5 is 15. 15 plus 3 is 18. Okay, so g of negative 5 is equal to 18. An input of negative 5 gives us an output of 18. Okay, moving on. The zero of a function. A zero of a function is an x value for which the output is equal to 0. So we're looking, actually, the zero of a function is where it crosses the x-axis. All right, so we're looking for the x value where it crosses the x-axis. In this case, we have a graph. We can just look at it, and we can see that the x would actually be equal to negative 2. That's the zero of the function. Okay, so we can also solve for it. If we're given an equation here, we've got 2x plus 4, we actually want to set our output to be 0. So f of x, or our y, is set to 0, and now we solve for x. Okay, and we solve for x just like solving an equation. Negative 4 is equal to 2x, and then we would divide by 2, and negative 2 would be equal to x, or x is equal to negative 2. So with the zero of a function, you want to make sure it's where the output is 0, or the y value. It's where it crosses the x-axis, and that's the zero of a function. It is not f of 0. Okay, f of 0 is when the input is 0. So it's not f of 0, it's setting your output to be 0. All right, looking at these, we're finding the zeros of the function. So let's let our output be 0 and solve for x. So we're going to do that by subtracting 1 from both sides and then dividing by our negative 2. Okay, when we do that, x is going to be equal to 1/2. All right, as an ordered pair, it would be 1/2 and 0, because that's where the zero of the function is, where your output is 0. Okay, we're going to set the output to be 0, negative x plus 5. We subtract 5 from both sides. Negative 5 is equal to negative x, divide by negative 1, and 5 is equal to x, or x is equal to 5. Okay, so our input of 5 would give us an output of 0. That would be the zero of the function. Okay, if f of x is equal to 3x minus 1 and g of x is equal to negative 5x, find each value. So here, notice we're looking for f of 2. That means we're going to use the f function. So we're going to let x be 2, and this would be 3 times 2 minus 1. 6 minus 1 is 5. So f of 2 is equal to 5. G of negative 4, we're actually going to use this function. So it's going to be negative 5. Well, we're going to let x be equal to negative 4. And it's going to be negative 5 times negative 4, which is positive 20. All right, number 9 gets a little trickier. Okay, notice we have f of negative 1, but then we have plus 1. All right, so first I'm going to take f of negative 1. So I'm going to use the f function right here. And every time I'm going to let my x be equal to negative 1. So it's 3 times negative 1 minus 1. Okay, but then what I want to do from there is actually add 1. Okay, so this becomes negative 3 minus 1 plus 1, or negative 4 plus 1, which is a negative 3. Okay, so be careful with that. It's a little bit different. Okay, looking at our next example, our input is x minus 1. So in this case, we're going to use the g function. So g of x minus 1, we're going to let x be equal to x minus 1. In every place we see an x, we're going to put x minus 1. So we've got negative 5 times x minus 1, which is negative 5x plus 5. And that would be our answer there. Okay? All right, so you can work on the exit ticket, try these problems, and we'll come back and go over them in a few minutes. Okay, so for the exit ticket, it's a little tricky. We've got f of negative 1 plus 1. So in this case, we're going to let x be equal to negative 1. We're going to use this function, and x is going to be negative 1, so we have negative 1 plus 1. Oops, sorry, just made a mistake here. Oops. Okay, this is going to be, all right, negative 1. Let's get this back. Oops. Back on pen. Okay, it's going to be negative 1 minus 1, but then we're going to add 1. So negative 2 plus 1 would give us a negative 1. Our second example, g of x minus 1, we're going to use the g function here. In every place we see an x, we're going to let x be equal to x minus 1. So negative 3 times x minus 1 plus an x minus 1. And then I'm going to distribute and simplify. Plus x minus 1. This would be negative 2x plus 2. Okay, example number 3 in the exit ticket, we're finding the 0 of the function. So our output is 0, and we solve for x. Okay, I'm going to subtract 1 from both sides. Negative 1 is equal to negative 3x, and then divide by negative 3. Okay, our x is equal to 1/3. And the final example looks weird, but g of b plus c, we're just going to let our x be equal to b plus c. Every place we see an x, we're going to put in b plus c. So it's going to be negative 3 times b plus c, but then we need to add 1. We're going to distribute and simplify. So there's our final answer. Okay, bye-bye.